Welcome to today's NWA webinar series. Today's performance presentation is improving packaging line performance with OEE and SPC. We are very lucky. Today's presenters are Dan Engelhard, Director of Business Development and Marketing at Stone Technologies, and Wendy Armel, the Senior MES Analyst at Stone. Before I turn the presentation over to Dan and Wendy, let me just briefly go a couple of housekeeping items. First, all participants will be on mute. However, you may at any time raise questions or chat through the panel on the side of your webinar screen. Also, we will be posting a recording of this presentation. You should receive an email notification of that early next week. So if you have other colleagues and friends who would like to hear this material, please feel free to send this information around. So without further ado, I will turn the broadcast over to Dan Engelhard.
Thank you, Jeff. Welcome. Again, my name is Dan Engelhard from Stone Technologies. What we plan to do today is to first give you just a one-slide quick background on Stone so you understand where we're coming from. And then really, Wendy's going to do a lot of the heavy lifting here. Wendy has been doing OEE systems for past 8-9 years, specifically focused on OEE. She can talk about what OEE is so we have a baseline, and then supporting the data, how the data supports for real-time OEE data collection, and then why invest, why do we even do this, what's the benefits and of applying, and then what's new, the new twist to this that's we've been discovering here in the last year or so is, you know, some people use SPC, some people use OEE. We're finding applying both of them and marrying them together can uncover some good information to go back and improve the process. And we're actually going to show you real live data from a real live customer and using the tools and run it through ROE data and run it through the Northwest Analytical SPC tools. And then we're also going to talk about driving operational performance and how this can improve your process. Okay? Next slide. So just a quick background on Stone Technologies. Stone's been around for 15 years. We've been doing OEE systems for the past decade plus. We focus in the MES and MOM, but we also do plant floor operations. If you see on the slide there, when you say MES or Manufacturing Operations Management, there's a variety of topics that fall underneath that umbrella, and we do all of these. The other thing is our organization's focused. We have a lot of veterans in the organization. We do not hire new grads or anything like that. Our average tenure is about 21 years. And we also, you know, part of an OEE system, you have to have the data collection from the plant floor, from the PLCs, the CNCs, and all the operations on the plant floor. We do that as well as pull that data into the system and then present it in an OEE package. Okay? So that's a quick on Stone, and if you have any questions throughout, you can put in the chat room, and we'll be more happy to address them throughout the course of the presentation. I think we got one quick poll question, and then we're going to turn it over to Wendy Armel from Stone. Yeah. So the quick question for everyone is, you know, what systems do you have in place today? Are you doing OEE, or is it manual, or are you doing it automated? And then same thing with SPC. Are you doing manual or automated? If you could click on which one applies to you, we'd appreciate it. Just try to get some feedback from the audience. Okay. With that, I'm going to turn it over to Wendy Armel, who will give you a quick introductory and then go through a product demonstration. Wendy? Oh, I think we just got her unmuted.
Thank you, Dan.
There you are.
Yes. I'm just waiting for the quick poll to go away so that I can take control of the screen and advance through the slides.
Okay. Okay.
Thank you, everyone, for attending this afternoon. Before we get into the actual presentation, I wanted to start with a background about what OEE is so that we all start at the same place, so we understand the calculations and the pieces and parts that we're going to be dissecting with SPC today. When you take OEE, it's a simple calculation of looking at your availability times your throughput times your quality. If you dissect each one of those three segments, you're looking at availability being your running time divided by your available time, run time. In this example will be the actual time that you're physically producing a product. Available time is the amount of time that you should be producing product. The throughput calculation can be looked at your total parts through the system times your ideal cycle time or your theoretical maximum divided by your run time. And then your quality calculation is looking at your good parts divided by your total parts. If you reduce that down, it becomes your ideal cycle time times your good parts. Divide that by your available time. Throughout this presentation, we'll be talking about those individual pieces, and we're also going to start talking a little bit here about what makes up, what can impact those different pieces of the calculation. The data that was collected for this example throughout here was an actual line. It's a high-speed packaging line, a filling line. It's an actual production line that was in production on one shift that we're looking at. The data was gathered through Rockwell Software's Factory Talk Metrics product. And in order to understand the impacts of your OEE calculation, there are several things that can happen. You're going to see we didn't get into all the details, but I want you to understand that there are events that happen on a line that can impact it. For example, a fault occurs. When a fault occurs, you're available to produce product, but you're actually not running and producing product. Therefore, your run time gets decreased. Therefore, your availability calculation becomes the impact to the OEE calculation. There's also ways to gather information like a state. You'll hear that in the industry, machine state, utilization state. For example, running faulted, upstream, downstream, blocked or starved conditions, operator stops, changeovers. Depending upon how you configure your automated data collection system, the mutually exclusive machine state will impact the amount of available and or running time that is being gathered for your OEE calculation. I touched about events here. When you start looking at the pieces and parts of your OEE calculation with SPC, you'll begin to start to find places for areas of opportunity for improvement. When you find those areas of opportunity, you want to start to dissect into the events of what were occurring on your line or at that location on the line for that specific time to understand how you can reduce those occurrences to improve your performance. So there are events that can be gathered automatically, meaning anytime something happens in the control system, it's known. Also, some of our clients will do operator inputs, things that actually when an operator stops a piece of equipment, maybe an operator stop for an e-stop or a light screen or something that the actual operator stops a piece of equipment, that also can impact your performance. Quality, rejects is a big part of the OEE calculation. But also what's important to understand, when you're doing an automated data collection system, if you just look at the overall piece of the quality calculation, it's going to get your good parts divided by your total parts. The difference there is the scrap parts that come through the system. With an automated data collection system, you could actually quantify and qualify the different types of scrap or rejects that are coming through the system. What I mean by that is we're going to be taking a look here at a filling line. For example, if you had a filler and you had 500 pieces that came into the system and only 400 came out of the system, meaning you had 100 scrap units inside that filler, you could, in theory, have 5 different reject counters that could be divided up and tell you how many of each one of those different types of rejects happened within inside that filler. So automated data collection systems can provide a lot more detail that will help you to understand when these different calculations are outside their range or breaking the lower control limits or upper control limits that are happening. So why do you invest in OEE? It helps to reduce manufacturing costs. It can improve your return on assets. It can allow you to increase your capacity without adding new assets. It helps you to identify areas where you can save money. Focuses on capital spending for maximum return. Will allow you to react effectively to change, identify problems quickly, and make decisions on facts, not assumptions. Some things that were said here were pretty important. Allows you to effectively react to change. Remember, most systems, if they're after the fact, you are reacting. You're not being proactive. With gathering information from a real-time data collection system, it becomes very actionable because it's fresh, it's not stale. And then applying SPC on top of it helps you to easily identify those areas in which you should be focusing on for areas of improvement. So why real-time OEE? Why is this so important? Real-time systems collect information that paper systems cannot. Think about micro-stops. A 2-second stop, rarely does someone remember that at the end of the shift. A 10-minute stop, they remember. But what if that 2-second stop happens 25 times or 500 times throughout a shift? Those add up to be impacting your overall performance. Also, with real-time data collection systems, there is no human subjective or interpretation of what's taking place. It becomes very, very precise. If you're the filler operator and it goes down for 2 minutes, it may feel like 10 because it's impacting your production and your efficiency at your location. Again, automated data collection systems takes out the human interaction or the human interpretation of the information. Also allows for accurate unit counts. I had that example before when you take information that goes through the filler, the pieces of parts that are moving through it, it's actually with a photo eye or some other medium actually gathering that information so that it is accurate. There is no guessing about what took place. Again, real-time systems make information available immediately. The information must be actionable. If it's old information, for example, manually entering it after the end of a shift or the next day, it becomes less actionable. Real-time systems allow proactive responses to problems. People think in real time. They think, what's happening now? How can I make a change now to make things better? If it's the next day, it's awfully, you can improve for the future, but you may not have had the same result had you had the information real time. Real-time systems require less administration. Paper systems require extensive data entry for data to be analyzed. Real-time systems typically try to collect at least 90% or better of the information automatically. It also allows the information to be easily available to everyone. Web-based data availability for data analysis, analytical reports for detailed analysis. You're also going to see that the SPC analysis that we've done here could not have been so easily done if we did not have an automatic data collection system. Real-time systems convert data into information. People need information, not data. Information allows them to make better business decisions. Different people need different information. We've talked about the 3 pieces of OEE, availability, quality, and throughput. There's 3 different consumers of that information. Your throughput is your production supervisor. They want to know how much is moving through that line or through that piece of equipment at any one given time. Your availability calculation is your downtime, your maintenance people. They need to know when those lines are down or when those pieces of equipment are down and for how long and why. Quality, your quality labs, they want to know what's going on with the product and why, if it's impacting the overall efficiency of the system. When does that happen, why, and for what reasons? Information must be presented accurately and consistently. And information must lead users to performance problems and their solutions. Again, information must be actionable and it must be accurate for people to make the best decisions to improve their business processes. So why do we apply SPC to OEE? It helps us to quickly identify the areas that are having difficulties in either quality, throughput, or availability. It gives you the ability to do detailed statistical analysis on an automated data collection system, and also provides the ability to alert personnel to predictive trends and operational data. So for today's example, we're actually going to look at SPC applied to an overall line. We're going to be looking at the pieces throughout the line of the OEE, throughput, quality, and availability. And then we're going to go detailed into a specific work cell. So our first slide that we're going to be looking at is looking at an overall packaging line. And that packaging line is arranged as the depalletizer, a feeder, a filler, a labeler, a case packer, and a palletizer. And looking at this, this is the actual, the line itself is a real line from a real customer with real data for one shift. The names of the pieces of equipment have been changed. The only one that is the accurate piece of equipment is the filler. For those of you who are on filling lines, you will be able to relate to the fact that the filler is the blood or the heart of the line. Without that filler, the rest of the machines, you don't make any money if things don't move through that filler. So at a high level, we're going to start out here first taking a look at the overall line and some SPC charts of the overall line. And then we're actually going to focus really heavily into the filler and understanding the different pieces of information that we can obtain by applying SPC to automated OEE data collection systems. So this first chart here is that SPC and process-based analytics allow us to determine the range of variation and stability of OEE performance and enable process engineers to manage and improve line performance. Here you will see box plots that show us the OEE variation at each work cell. Again, the work cells are listed down here along the left, and each piece of them, their individual box charts are shown in the center. So the box plots are based on a median, which is the center line, and then the quartiles. You're going to notice these little stars, they're statistical outliers. So if you take a look at these, at the filler, this is our median, and these are our quartiles. So 50% of the numbers that were taken, of the statistics, were below the median, and 50% are above the median. 25% are in this box, and the upper 25% are outside the box to that exterior hash mark. So what's interesting about this chart is that you can actually see that the case packer and the palletizer are typically up over 100% OEE in a lot of their cases. What's interesting about that is when you look at this, you can see that they most likely have sped up this line during this period of time for this one shift that we're looking at on June the 1st of 2009. And they sped it up at the end of the line to feed out the line. Again, remember, the line is only as fast as the filler can produce. But you can see that they're doing their actual speed is actually probably faster than their theoretical maximum for these pieces of equipment. So let's take a look at our control limit charts here for each piece of equipment on the line. Starting at the depalletizer, the feeder, the filler, the labeler, the case packer, and then the palletizer. Control charts show the process stability to each work cell and provide signals to the engineering staff whenever there's a process instability. You're going to notice in these control limit charts there's an upper control limit and a lower control limit and a center line. Becoming a little more familiar with these, also the little stars or asterisks are actually rule violations. So placing all 6 work cells together on one chart allows you to start seeing the trends that are happening and allows you to easily identify areas for opportunity that you may want to drill down into further. For this exhibit today, we're only going to be focusing in on the filler, very detailed. But if you take a look here, you're going to see that on the depalletizer, we had 2 occurrences that broke the lower control limit. We had some statistical anomalies here that are happening at the end of the shift, where the OEE on each one of these pieces of equipment is exceeding or close to the 100% mark. So when you take a look at these, you want to start looking at the areas for improvement, focusing on the opportunities in each area. When you have things like this, these statistical outliers that are taking your OEE at close to that 100%, you want to know what is going on at this period of the shift that you wish that you could replicate for the rest of the shift. What's happening at these lower control limit breaks that you want to reduce or eliminate so that you can then bring up your calculations. So if you have an automated data collection system, you'd be wanting to dig into the details of the events that took place when these lower and upper control limits are taking place. What happened on the line at these points in time that we can eliminate in the future? And you're going to again see here on the palletizer had some breakings of the upper control limits. We're going to focus in on the filler. Again, we're starting at the high level, which is the OEE portion, the calculation. And then we're going to get down into each one of the pieces of the availability, quality, and throughput within inside of the filler. If you take a look at this filler, you're going to see that we have 3 areas, again, for opportunity. We have some lower control limit violations. And looking at this, you're going to notice, if you look closely here, our run seconds was only 74 seconds of the available 600. This is looking at a 10-minute window. That tells me that something impacted the system and took it down for 525 seconds. That's a lot of time for it to be down. So whatever's happening at this point is something that you want to try to eliminate. With SPC analytics, we can drill down into each one of the individual work cells, and then we can look at the stability of the OEE KPI at this filler workstation. The next point that we're going to explore is the second lower control limit violation. What's interesting about this one is that both the availability, the throughput are both down. And you're going to notice once you start taking a closer look at the pieces of this statistical analysis that the quality is actually down here as well. And for those of you who are looking at this quality calculation and thinking 98%, well, that's really great, this line typically does have a very high quality rating, and it typically has a very high OEE rating as well. This shift has some anomalies in it, but typically this shift, this piece of equipment and this line runs at a very high efficiency level. So again, these are they're quickly helping you to identify over a period of time where are actual places that you could eliminate some of these outliers. When taking a look at this with applying SPC, it becomes very apparent very quickly at individual pieces of time of how to, where are areas for improvement or opportunities for improvement. So our third location that we're going to look at on this filler for OEE and for an area of opportunity is at the end of the shift. We have a lot of rule violations here. Look at this OEE. The throughput is over 100. The quality is at 99. What's taking place at this point in time to have such a great impact on the line? How are these operators getting this line to run at this level, and what can we do to make this line exceed all the way up here to the beginning of the shift? Those are areas of improvement. All of these, again, the availability, the throughput, and the quality are at a very high level. When you think about rule violations, think of things like when you flip a coin and there are way too many heads. For example, maybe you flipped a coin 10 times and heads came up 9 of those 10 times. It's pretty statistically unlikely that that would happen. And that's what this is showing us here. It's statistically unlikely that this would happen. So it's important to understand what was taking place here so that we can replicate this in the future. Now we're going to take the actual individual parts of the OEE calculation on this filler. Let's take a look at the availability. This first point here that we have is telling us, again, that the run seconds were very low during this period of time. So what do we want to look at to actually eliminate and say what was the fault that occurred that reduced our run time? And how can we eliminate that from occurring again? Interesting that this is the exact same points that were there for the overall OEE number as well that we're looking at. Our second lower control limit violation that we're looking at, once again, has a low amount of run time here. But it's also important to start taking a look here at other things that we're seeing within inside of all the information that we can display on these points. Look at this cycle time. Our ideal cycle time is 0.08 seconds per unit, and they're actually running this piece of equipment at 0.14 seconds. It's actually slowed this piece of equipment down at this point in time as well. So by allowing you to display all this information with NWA's product, it can give you a lot of detailed information to help you start looking at places for areas of improvement. Let's take a look at our throughput. You're going to notice something interesting on this one. There's a new point of opportunity here. that we haven't seen yet so far. When we take a look at this, you're going to actually look here and say, what's the throughput? It's how much product are we moving through the system. Take a look at the ideal cycle time versus its actual cycle time. This machine speed was slowed down here. It was not enough to produce it, it exceeded the lower control limit. Even though the system does not say that it's out of control, there's only one point here that it's happening at. This helps you to understand what happened at this one point that we can change and make things better. When you take a look at this system, it runs very well. Look at these throughput numbers. Look at that OEE number that we had. I mean, most people would really love to have a system that's up here in the 80s to 100, sometimes better. But there's still areas of improvement, and applying SPC to it makes it very clear of where those areas of improvement could be focused on. Let's take a look here at our quality of the filler. Interesting to see that we have negative quality impacts at the beginning of the shift. We then have another one here towards lunchtime, towards the middle of the day. When we take a look at this, we're going to see that, well, our scrap parts really aren't that bad from what we would think, but for this piece of equipment, it sure is. This piece of equipment runs so well in the quality, you can see here that there's really barely any scrap at for this shift. But by applying SPC, it became very, very apparent that at this point in time, something happened that impacted our quality. You're also going to see that our availability calculation at this point in time, the throughput and the quality, they're all down right now. So just because it's your quality, you may be able to see by applying this tool that you could start looking at some other things that are impacting it. Maybe you had a fault that occurred that actually took down the availability calculation. Maybe the throughput calculation, maybe they actually changed the speed, which you're seeing down here. The speed is actually increased versus that ideal cycle time. And again, this would not normally be easily seen if you were not applying a tool such as this to it to see that it is at 98.7. Most people think that's a great quality rating. So our final thought is to make OEE and performance management a part of your manufacturing culture. Remember, when applying a tool like this, it is a culture change. It's a way of dissecting the information to make changes. Change is not always easy for an organization, but having the tools to identify where those areas of change are, those opportunities for improvement, makes it easier. You can apply SPC to automated OEE solutions. As you can see, we used an automated data collection using Rockwell's Factory Talk Metrics product, applying Northwest Analytics SPC tools to it. It allows it to become very apparent where your areas of opportunity are. These types of solutions allow you to focus on information and not data. Again, information is actionable. You can make change based on it. It's important whenever you're putting one of these types of solutions in, you invest the time in proper planning. And then our last statement is don't go it alone. Learn from others and what they've done in the past so that you can have a good system that helps you to get to the business results that you're looking for. I'd like to thank you for your time today. We appreciate each one of you attending. And now I'll turn it back to Jeff for some other questions that he has for the panel.
Thank you, Wendy. Okay, let me review our questions here. Quite a few. Let's see. It says, were those control charts generated from OEE or from Northwest Analytical? I'll let you answer that.
The control charts were generated from NWA's product, Northwest Analytical.
Mm-hmm. Indeed. Yeah, I know from our perspective that one of the virtues of putting these kind of systems together is to link these different components, and you end up with something much greater than the whole. What is your experience in that kind of application? I'm sure Stone has done a fair amount of this.
Yeah, the data acquisition is the piece that's important. Without the data, you can't apply anything else. But again, depending upon the audience in which who's going to be looking at the information, it depends on the tool that you're applying. For quality, for people who are in the quality area, the SPC is a fabulous tool for them to apply to it. So we apply a different variety of tools to the data that we acquire from a solution.
Right. Yeah, I was noticing in that first poll that 38% of the attendees were using manual OEE and 71% were using manual SPC. So that sounds like there's a lot of opportunity out there for people to get better performance. What have you observed as you bring people on to automated OEE as far as the kind of impact that has on their process engineering and management?
For us, the hardest thing is to get the infrastructure in place. So that is a culture change in bringing in automated control systems. But taking people from that manual to that automated collection is not an easy process, but it's a worthy process in the fact that there is no longer that human interaction or human interpretation of what's taking place. So everyone becomes very objectionable about it. It's no longer a subjection. So it allows them to become focusing on the issues and not the interpretation of the information.
Right. All have data. What is your experience been as far as the amount of time and the amount of people involvement to make this transition?
We typically, when we put in a solution like this, we typically try to do a functional requirement specification up front, and that involves looking at meeting with production personnel, operations, IT, engineering, and management. That is making sure that we understand everyone's perspective of what's important to them to make the business decisions in their area to impact change. Once we understand what each one of their important areas are and how they're looking to look at the information, we can then design a solution that will meet all of their needs for each one of them. As I stated before, you've got the 3 pieces of OEE, the availability, quality, and throughput, and typically there are 3 different audiences for that information. So understanding what's important for them to be able to impact their change is very important up front. As I stated in the last slide, it's important to do proper planning up front. If you don't have the right data being acquired, you can't do the right analysis to make the decision. Understanding that where you need to get that data, how it needs to come out of a control system, how it needs to be stored, how it needs to be maintained is crucial in keeping these systems going long term and making the right decisions with them.
Yeah, and here an individual evokes a question that you made some mention of earlier in your presentation. So there's a more detailed program that completely takes the human interaction out. Because in my experience, though, operators are so busy that they may guess at the cause of the downtime or leave it as a fault code required. I guess along with that is, what kind of improvement in the data and the information quality of the numbers themselves are you typically seeing here, so that it's part of the benefit of doing this?
We typically try to work with the customers to make this as automated as possible. Try to have as minimal operator intervention as possible. As the individual stated, operators need to run a line. Their job is to get production out the door. It's not to enter information. They need to get those lines running and running as best as they can. So what we try to do is do a lot of information on the control layer, doing lots of different indicators to understand what's taking place. If I'm sitting at that filler and I've got a downstream, if that palletizer is faulted out, I automatically put that filler into a downstream delay function. Therefore, it's not impacting the efficiency of that filler, it's impacting the efficiency of the palletizer. But when that palletizer is in that faulted state, you want to have control layer programs in place to understand exactly what's happening and for how long. So that you can start to quantify, okay, so many times we had jam number 52 happen, or the drive faults out. How many times does it happen and for how long? It can help you also when you're starting to look at those types of things. They can be indicative of things that could be arising, that could occur, becoming maybe large maintenance problems. So when we look at these, we try to make them as automated as possible, pulling as much from the control system as possible, taking that human interpretation or input out if we can.
Good. And how is your operator and staff acceptance been experience?
It depends on the location, and it depends on how management presents the information to the operations and the staff. If you present the information in a way that it's looking to improve performance, and it's looking to use it as a training medium and not as a disciplinary action, it becomes very widely accepted. And what I mean by that is I have worked with plants that have used it to say, listen, second shift outperforms first shift. What does second shift do that first shift doesn't understand? And they'll take it and actually use the operators and take the second shift operators and train first shift of how they're running the equipment. It could be a very small adjustment that makes a huge benefit on the system. I've had other clients that don't use it in that productive of a way. They'll use it as more of a bat. They use the information and they don't use it in a productive fashion. They don't become as successful with it because the operators then feel as though it's becoming a problem for them and then it's not helping them. So that's why we ask for management to be involved with these projects from the beginning to understand that it is a culture change. It's about empowering individuals with the right information to make the best decisions. Great example on the line you're actually looking at today, there was an operator who kept seeing a very small fault that was happening. It really wasn't impacting the overall system very much, but it was very short periods of time. And he started questioning management about why does this keep happening? Why does this keep happening? When they found out they actually were just putting the wrong type of oil into the equipment, and that was what was creating that fault. So, but having that information out on the floor for the operator, he could see that that was happening. We hadn't actually, didn't show that in this presentation, but we actually did a lot of line status display that shows exactly what's occurring, and he noticed it. By empowering that operator out on the floor with that information, he was able to make a change that actually impacted the overall system.
Okay, thank you. Do we have any additional questions? Let's see, I think that's about it for that. If anybody else has any, please submit them. If not, we will thank Wendy for a very informative session. It looks like we've spoken to people's needs here. Well, Wendy, thank you very much. I really enjoyed this presentation. As mentioned earlier, we will post a recording of this that you may circulate to your friends and colleagues. And again, thank you very much from Northwest Analytics for attending this webinar. And we thank Wendy and Dan for presenting this useful information. Hope you may all have a good day.